Seismic acquisition geometries and seismic data. Here is one of the key references used to develop this class. The surface of the Earth is either solid or covered by water. So as a seismic acquisition is mostly carried out on the surface of the Earth, it is important that we start by a review of seismic acquisition in both water and solids. The concept of homogeneity, heterogeneity, acousticity, and elasticity controls the type of waves that we can generate and the physical quantities that we can record. Therefore, their implications for seismic acquisitions are profound. For instance, the division of seismic experiments into land and marine is primarily related to the fact that in marine cases, the acquisition is conducted in water, which can be treated as acoustic and homogeneous, whereas in land cases, the acquisition is conducted in heterogeneous elastic media. Actually, the differences between the various acquisition scenarios presented here come down to the difference between generating and recording waves in a homogeneous fluid and in a heterogeneous elastic medium, or solid. The fluid is generally considered homogeneous, with a relatively flat air-water interface. It supports only P waves, and both pressure variations and particle velocity can be recorded. In the last lecture, we described towed streamer seismics, including the notion of seismic events. We will now describe broadband seismics, that is, ways of widening the spectrum of seismic data. In seismology, broadband is a characteristic of data with a wider band of frequencies compared to data associated with conventional seismic exploration and production. In the marine towed streamer, the data have a usable bandwidth, typically from around 8 Hz to 80 Hz, whereas broadband seismic systems can produce data with usable frequencies from as low as 2 Hz to as high as 250 Hz. The additional low and high frequencies contained in the broadband seismics allow us to produce images of the subsurface, which readily reveal depositional models, something that is not generally possible with conventional seismics. Two of the major factors limiting the data spectra to between 8 and 80 Hz in conventional seismic systems are 1, the ghost effect, and 2, swell noise. The other major factor is that propagating waves attenuate with time due to various energy loss mechanisms that we will discuss in future lectures. The broadband approach here consists of designing the acquisition systems so that we can record data without ghost and swell noise, or in such a way that the removal of swell noise and ghosts become feasible at preferably the early stage of the seismic data processing flow. Our first objective is to describe how the effect of ghosts affects seismic frequency bandwidth. The second objective is to describe some broadband towed streamer acquisitions.